problem, we're going to use the calculator to find where this graph has some horizontal tangent lines, so where the derivative is equal to 0, and using the derivative graph, figure out where is this graph increasing, so where the derivative is positive, and where the derivative is also negative. So let's look at this original graph. And for my window settings, I kept my x window from -4 to 4 and my y mins and max from -10 to 10. So if I look at this portion of the graph, it looks like there are 3 places where the derivative is equal to 0. Down here, right here, and then here. So we can probably estimate what it is from the graph by looking at it, but it's going to be really hard to come up with the exact value from this original graph. That's where the derivative graph is going to help us. Here's the other thing. Let's say I want to know where is this graph decreasing. So the graph is decreasing from the left side all the way down somewhere, it looks like, to -0.5. But again, hard to tell what this exact value is. So what we're going to do is use the derivative graph to help us find those exact values. So I'm going to go back to my y equals screen. I have the original equation typed in, and I'm going to go ahead and have the calculator create that derivative graph, f prime of x. So remember, it's number 8 from math. We want the derivative. My equation is in y1, and I want to create the graph for all values of x. Now, I don't actually need to look at the original equation anymore, so just to make it a little bit less crowded on the screen, I'm going to turn off that original one. So if you go to the y equal sign on y1 and press enter, it's not highlighted anymore, so that means you're not going to see that graph. And then I'm going to ask you to do one more thing. I want you to go to y3 and plug in a 0, and you'll see why in a minute when we look at the graph. Okay, let's look at the graph, and let's look at just the derivative graph. And if you look at the screen, notice that the original graph is over here. Actually, sorry, that's not the original graph. It gives me the derivative graph. So this is the graph of the derivative. So remember in the original, we said the places where you have a horizontal tangent means that the slope is 0. So I see 3 zeros on this graph. So I want to find those exact values. Basically, we're looking for where's this graph exactly equal to 0. So we're going to do an intersection feature, and that's why I typed in 0 into y3. So if you remember, we can do intersection using second trace, which is number 5. And it's going to ask you a couple questions. If you only have 2 equations that you've got graphed here, it'll automatically jump to the first curve, so you don't need to do anything. Just press enter, and then it will automatically jump to the second equation, which is that equation y equals 0. So all you need to do is press enter. Now, the guess is the only thing that you need to move. I've got 3 points I need to find, so you need to tell it which one you want to find first. So I want to find this most left-hand point first. And then after you're somewhere around it, you can press enter, and it'll give you that exact point of intersection. It's exactly at -0.4317. And then I can repeat the process for the other 2 points. So number 5, intersect again. You just press enter, enter. Then when it asks you for the guess, though, now this time I want to move it over to get to that second point. Press enter. And there's your second point, 0.54087. So that's the second place where the derivative is equal to 0. And then the last one is intersection, enter, enter. And then I need to move that guess again so I can use that last point. And your last place where you have a horizontal tangent is 2.1409. So that's how you can use the derivative to come up with those exact values where it's 0. So now use these values to answer the other questions about where do you think f of x is increasing and where is f of x decreasing. You'll need to use these values that we just calculated.